We will now talk about collision geometry. This is a very important topic because most of the interactions that will happen within the RBD simulations are taking into account an underlying geometry that is not necessarily what you're seeing through the viewports. And to better understand collision geometry, it's much better to see it directly. So I will dive into the DOP network, look for my building demolition. So right now the building is RBD packed object 1, which doesn't really tell me much. I will change the name. I will just call it building. Select the node, and first of all I'm going to look for the display geometry. So this is the display of the actual geometry, of the actual model. So I will turn it off, and here under bullet data you will find a show guide geometry option that by default is off. And this is one of the things I like much better of the DOP networks. In general, the display of the guide geometry here is relatively fast. For some reason, in the RBD bullet solver, this kind of visualization is extremely slow. So sometimes you can only check one frame or probably a part of the model. But if you want to visualize very complex geometry like this building, it tends to go very, very slow. So in this case, let's just turn on the show guide geometry. You will notice here it will take probably half a second to refresh, but now we can immediately see it. And even if we press play, you can almost see the guide geometry refresh in real time. So let's take a look at the geometry representation options. The default geometry representation option will be the convex hull, and it's a kind of shape that you will use most of the time. So let me go back to the building geometry just to show you the detail that is being generated for this kind of pieces. So I will connect now the high resolution building. And if you remember, this version of the building has a lot more detail. So it has interior detail and edge detail. So let's concentrate on these pieces. Go back to the DOP network. So this is a convex hull. And if we see it through the wireframe, you will notice that all of these lines are convex. Bullet is much faster with convex shapes, although there is an option that it's called concave. I wouldn't recommend you to use this option because it tends to be much slower, especially with objects that have many pieces or much detail. And this would be almost the exact same contour that we have in the original geometry. So let's go back to the convex hull. And I will show you a few options that will apply to this convex hull shape. So first of all, we have the collision padding. And if I zoom here, you will notice that most of these edges are rounded. And if we decrease the padding here, for example, to 0.2, we should start to notice that these round edges or corners start to resemble more closely the original shape. And this will make the interaction with all these pieces much more precise. But at some point it will get slower and it will be more difficult, especially to take care of interpenetrating pieces. So what I would recommend usually is start with a default of 0.2. And if you notice pieces interpenetrating too much or those pieces that keep spinning in the ground, you may probably want to start lowering this value. But if your simulation is not seen from very close or probably you don't have that many pieces interacting, you may stick with the default or even try with higher values. Let's type 0.4 just for preview purposes now. But my final simulation was generated with the default value. So here you will see the contour is much coarser. So let's go back. to point to, and we'll take a look at some other geometry options. So another very interesting option is the box option. And initially it may look strange to just create a box representation of a more complex shape, but sometimes you don't need more than this to generate a convincing simulation. For example, again, if you have objects seen from a distance, or probably you have objects with very complex shapes but overall squared form, you can try and get away with a nice simulation. And of course, this will be much faster to generate or to calculate. Or sometimes you can use this shape just to prototype your constraints and your forces, just to iterate much faster, and then change to the convex hull for your final simulation.